the waterfront for different reasons. Some like the views. Others like access to the water. Waterfront living comes with unique challenges and responsibilities. What if you could create more waterfront access while helping to restore your waterway? What is a homeowner to do when their shoreline is eroding? Guidance from government isn't always clear. On the shores of the scenic Severn River in the Chesapeake Bay, homeowners Janet and Jim Clausen wanted to use their waterfront property to do more for the river they love.
The project was actually begun because we had high cliffs which were eroding quickly and large trees were coming down. So we had to do something.
Severn River is about midway up the Chesapeake Bay. 75% of the shoreline along this river has been altered or armored, hardened to prevent erosion over the years.
On part of our property, we had wooden bulkhead and stone revetment. And we knew that as the water comes down past those armored structures, that it erodes the land downriver of it. So it didn't make sense to go to armored structures, and we wanted, therefore, to do the living shoreline.
There has been this movement to try to figure out how do we get the shoreline stabilization components that landowners need and also protect or enhance the public resource. And so that's really what living shorelines are.
We have a cliff face here with a lot of energy coming across, again, this 13-mile fetch across the water where winds and waves are allowed to build, and it was banging up against the bottom of the cliff face. And then as a result, it would undermine that cliff face, and a section of the land would then fall down to the base and then erode with those waves out to sea.
How can you protect eroding land, keep harmful sediments out of the water, while maintaining access?
This is called a Dynamic Living Shoreline. Relatively new practice for shoreline stabilization that is set apart from all other methods. It employs the energies and tidewater to work for us.
In the state of Maryland alone, there are more than 3,500 miles of shoreline. Before humans began to develop along waterways, shorelines were dynamic, always moving and adjusting.
The 1844 Coastal Geodetic Survey, where they actually truly surveyed the entire Chesapeake Bay. You look at these old maps, and there are plenty of abatements, there's plenty of natural, I call it geomorphologies. So you go look in the 1890s, there's a massive amount of erosion that occurred in those two time periods. What's the reason? We had power boats between those periods.
All of the old practices that were bent on armoring against tidewater energies had detrimental effects in almost every case to the vital living resources.
So trying to restore some of those natural features that once existed here is really important so that we can provide habitat and help improve water quality.
We have observed where we have two other very successful dynamic living shorelines, an incredible habitat happening in the shallow waters.
From a purely practical goal of preventing erosion, the project grew to creating habitat.
Old school hard solutions fall short on water access, habitat, and pollution reduction.
The idea behind this headland breakwater approach is that it dissipates wave energy. So a revetment or a bulkhead is engineered to withstand the forces of nature. They are armoring against it.
I've been working with living shorelines for about 35 years now. And over the years, it's evolved.
So there's two different philosophical camps when it comes to shoreline protection. One is the defensive camp, which is building seawalls, bulkheads.
It's the conventional approach of, I'm gonna beat that Mother Nature. I'm just gonna armor that thing so hard that she can't possibly move it.
And there's the other philosophical camp, which you actually understand the shoreline processes and working with them. But you need to define what type of environment you're working in. And once you understand what is affecting the shoreline, then you can make intelligent choices how to select a design strategy to effectively manage the shoreline.
The focus on the design of these projects is on these shallow aquatic beds.
So you have two fixed points, and when the waves come in, they interact and create an abatement shape. And this is ubiquitous across the world.
By building these structures out further, the gap between adjacent headlands can widen, the bays get bigger, and therefore you can protect the same amount of shoreline with less rock.
Historically, the unwritten standard for encroachment channel works was 35 feet. Over the years, the Army Corps changed their values to allow for a 50-foot encroachment. This one is up to 110 feet.
The Kyle Point shoreline was over 900 feet, but this technique also works on smaller properties. The community of Pines on the Severn had an eroding beach and a failing bulkhead on their property.
I'm thrilled with it. I just couldn't be more happy with it. Immediately, visibly, environmentally, we've had lots of wildlife suddenly show up down here, but again, in how much enthusiasm the community has for this.
It provides waterfront walking access down a pathway, of which they can then pull a kayak right into the water or walk right into the beach.
This innovative and practical method has proved to be successful in 3 types of waterways.
We did a similar project, and it was part of the Assateague Island State Park, that utilized some similar techniques that they're using here at the Clawson Project. And one of the somewhat surprising but very fortunate things that happened there is how oyster spats sat and set on the headland structures that were created out there.
Our goal was to get rid of a wooden bulkhead that was a desert environmentally. Working with the state, we developed a plan to remove the wooden bulkhead and establishing a living shoreline, which literally lengthened the shoreline, because rather than a straight line, we had curves and loops, and we had grasses that went all the way down to the water. At the beginning of the project, we made arrangements to work with the Virginia Institute of Marine Science to document the before and after effects of this project.
Only polychaete worms existed on that site prior to its construction.
And then for 4 years after the project, they came back and sampled, very objectively documented greater diversity of species and greater numbers.
There were 7 species of clams. There were fish species, rockfish, even redfish found there.
That I've seen so far, science and just general naturalist observation, this is a really effective way to turn the health of this river around and to make it an even more valuable resource than it is now.
This regenerative design method is self-sustaining and works to combat the problems associated with sea level rise.
Because nature isn't an engineered box. So you have to find a balance between the permit, the engineering parameters, and ultimately the last step, which is the fine-tuning and the art.
Dynamic living shorelines are the wave of the future because they deliver so much for the homeowner, the wildlife, and for better water quality. Take advantage of new techniques and get the most out of your waterfront property. Visit dynamicshores.com for more information on dynamic living shorelines, or contact your local or state government.